one is for those who are unable to come. Berapa orang sudah kan? 19. That mean they are... Okay. Yeah, man. I take the attendance here first. So I take a picture here. Okay. Then save the photo. And then I take a picture here again. Sekarang sambil attendance kamu lah. Okay. Through the gambaran ni sajalah. Alright. Let's share with you what we want to do today. Paper 1 here. Where is it? New note? This one. Alright. So I hope everybody, what do you call that, not so tired now. So I don't want to spend too much time doing the question by question lah. So what happened is I have prepared a pointer for you. So what is included in the pointer will be all those necessary information that you must be able to apply during your paper 1 this coming Monday. So we don't want to waste any time now. Let us start the pointer guide. Can you see all this pointer guide here?
Yes.
Yes.
Can you see the red color laser pointer?
Yes.
Yes.
Good. So the first thing that you must be good at is the vector and scalar. Okay, vector and scalar. So you must be able to determine this one. I put a star here. This one is very, very important. Yeah, put a star here. So you must be able to determine the resultant force for two vector. So example like this one, you have let's say your A is 4, your B is 12. So in order to get the resultant force, you can use a parallelogram, or you can use the maths punya method lah, which is the C square equal to A square plus B square, and then you will get the answer about 12.6. So this one, I hope you don't make any mistake finding the resultant force for this coming Monday. And then the number 2 that you must be aware is the prefixes. So prefixes is all those, symbol to represent the standard form. Because if you always write down your answer in standard form, it's just very, very tedious, very long. So make sure that you know all this. So we start with a small p. This is a peta. Okay, peta. Let me write down here. P stands for peta. And then T is the tera. Ada arga. Okay, this one is the giga. This one is the mega. And this one is the kilo, and so on and so on. So pastikan you know all this. 2 of them will be out this coming Monday. Yeah. So pastikan kalau kena soal nano, nano is -9. Giga is 9. Yeah. And kilo is 3. So all these prefixes, please make sure that you know the number. All right. Next one, number 3. Try to revise back all this. Ani yang dalam the paper 1 punya content tu. I try to summarize. Pasalnya if I do overall one by one, not enough time. So I just give you the pointer lah. Soalannya is about this one. Kamu practice dalam past year lah. So number 3 is of course the famous uncertainty. So there will be, I don't know, maybe A equal to B times C ka, A equal to B over C ka. So to get the uncertainty, you need to do the fractional uncertainty, just like what you see here. Delta A over A equal to delta B over B. Kalau addition, just add on sajalah. If you have addition, or if you have addition or subtraction, let's say A equal to B minus C. So the uncertainty of A is only you add the uncertainty for each of them. So you no need to do the fractional uncertainty. And then number 4. I remember this one is done by Faiza. Yeah. She talked about the game thingy, and then who is a good shooter and so on. So number 4, you must understand the idea of precision and accuracy lah. So for example, this one, you see all the cross is in the center. The center represent the true value. So the center here represent the true value. So I can say that this one is precise and accurate. Yeah. And the other one here, as you can see, the cross is far away from the true value. So this one is not accurate, but is precise because they are very close to each other. The range is very small. All right, next one. This is the typical one. Remember the equation of motion under kinematics. Yeah, V equal to U plus AT, S equal to UT plus half AT square, V square equal to U square plus 2AS. One good news is there will be no projectile in the paper one. Yeah, no projectile. So I don't know whether it's a good news or bad news to you. But there will be only one dimension only. Yeah, one dimension. Contohnya macam a stone falling down to the ground. Calculate the S and maybe the time taken. So no projectile. Yeah, it's only one direction only. So you apply lah. You apply all these three here, and you solve the distance and the time and whatsoever. All right. Number 6, we have dynamics. So dynamics is about motion to do with the forces. So of course you have F equal to mg, or sometimes you rewrite this one as W equal to mg. Sama sajalah. Yeah. And then you also have this one, the famous one. This is the Newton's second law. Yeah. This is the Newton second law. Rate of change of momentum. And then also you have the old style one, this one, just in case you need it, F equal to ma. Forces. Now, forces will not be so easy for the MCQ. Normally in forces, we will give you a free body diagram, free body diagram. So example, you have a stone. So when a stone is falling down in the air, it has two forces act on the stone. So the first forces is called the weight, which is downward. And because the stone is moving, you will have a air resistant act opposed to the direction of the motion. So the idea about free body diagram, you need to analyze lah. So if the weight is equal to the air resistance, therefore the stone will have zero resultant force. So that means if the zero resultant force means acceleration is equal to zero. Therefore, they are having a constant velocity. In this case, it is falling. We will call it the terminal velocity. Yeah, you stop me. If you have anything on to ask, I just carry on sajalah. The second analysis will be if the weight is more than the air resistance, then we have acceleration, the stone speed up. If the air resistance is greater than the weight, therefore we have deceleration. That's why we have slowing down. Another example of free body diagram is when we study the cylinder in a liquid. Yeah. So we study the cylinder in the liquid. So inside a liquid, if the cylinder is moving, is moving with constant speed, then you have three forces act on the cylinder. So you have the weight, you have the upthrust, you have also the drag. Drag is the macam air resistant lah, but in the water, we call it the drag lah. Yeah. So we have the summary is weight is equal to the drag force plus the upthrust. Okay. So this is something to do with the upthrust. And then we also have momentum. Yeah. Momentum, of course, is this one, P equal to mv. So you'll be tested. You'll be tested in your paper 1 about elastic collision and elastic collision. So you make sure how you are able to apply this one. Yeah. So you look for past year, asalkan ada momentum, you practice lah. Yeah. And then we have moment. Moment, they are, this is the typical moment, the one that you see from the screen here. This one is the standard one. Not really come out lah, this one. This one not really come out. What you'll be tested will be something like this. So you look for past year paper yang ada macam gambar macam ni. Okay. Kalau kena jackpot, that senang lah, is a free mark for you lah. Sini you need to be able to calculate the moment lah. So the moment will be force time distance, clockwise and anti-clockwise. So you pandai-pandai lah. You split up the tension into two component. Okay, two component here. So you then apply your you apply the moment here. So this one is the first moment. Let me do a highlighter here. This one will be the first moment, and the other one will be here, the yellow one. This another moment here. So there are two moments there. You go and figure out lah how you do the calculation. But number 10, wow, there's a lot of formula again. I remember during our presentation, some of you write down all those formula lah. So this is the time you have to apply lah. All those work done, kinetic energy, potential energy, or even the elastic potential energy, half kx squared. And power, we have work done over time or energy over time. And there's a new one in your AS, yeah, in your A level. This is the new one. We have moving power equal to FV. Efficiency, yeah. Can you see the star I put there, the 2 star there? Just now, I think I saw some question on this efficiency. So try your best to apply the whole thing here lah, yeah, the whole thing here. All right, pressure, we have, of course, F equal to MA, and this one is pressure in liquid, yeah, in liquid, or in A also can, yeah, or in A. So these are the two formula that you must remember. And then we have the next one is the deformation. So deformation, I think I just scanned the paper. Yang keluar, this one, yeah, this one is the one that will be tested. This one, yang modulus ledak. So you have to apply Hooke's law lah. Yeah. So Hooke's law is something like this law. You have a graph of F against X. Then you plot a graph, it will be a straight line through the origin. So the gradient will be the spring constant, and the area under the graph here will be the work done, yeah, to stretch the spring or to compress the spring lah. Now, this another one you need to be aware. Kalau ada rubber band, yeah, rubber band ia punya property is a bit different from a spring because the pathway is not straight line. So for example, this one is you loading, yeah, you add load to the rubber band. This part is the unloading. Okay, so they follow a different path and they will not be the same original length anymore, yeah. So just to share with you, kalau paper 1 ada soalannya, what will be the energy to stretch the rubber band? So the energy to stretch the rubber band will be the total area under this graph here. It will be A plus B. Okay. What will be the energy released during unloading? Yeah. So during unloading. Okay. So it will be B. This one only. This is only the area that will release. And the A here, the extra side here will be energy loss as heat, yeah, energy loss as heat. So this is about deformation. And then for wave, okay, so wave, we also have a lot to cover. Let me just emphasize on this one lah. This wave CRO, I put a star there. That means is coming out, is a bonus, yeah. Now, contohnya, let's say you have a time base, yeah, you have a time base set to 4 millisecond per unit. Y gain 2 volt per unit. So what is the per unit mean? Per unit mean every one box, yeah, every one box. This one is a per unit. So if it's a 4 millisecond per unit mean for this one box, it will take 4 millisecond. So if I want to find out the period, okay, the period will be this one. This one will be a period. So period will be the time taken to complete one oscillation. So if I go and count the period, it will be 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 of them. So my answer will be 8 unit multiply with 4 millisecond. You will get 32 millisecond. Or that's why you can get 0.032 second lah. And then the next one, I want to find out the frequency. Frequency is simply 1 over the period. Yeah. So again, the same thing also. I just divide 1 over 0.032. I will get the frequency. Now for amplitude, it will be this one. This is the amplitude. This one here is the amplitude. This is the amplitude. So it's the biggest, because I want to find out the maximum amplitude. So if I go and count the box, it will be 1, 2, 3, 4, 4 boxes. So it will be 4 boxes multiplied by 2 volt. Why is it 2 volt? Because every 1 unit is 2 volt. So at time 4, you at time 2 you get 8 volt. Yeah. So these are the wave thing that you must be aware. Cari dalam pasir yang macam ni. I remember ni banyak ni dalam your pasir booklet soalan yang macam ni. You try to practice. And then we also have this electromagnetic spectrum. This one is a little bit headache lah. Ya, pasalnya kau mesti ingat the the susunannya, and then you must also remember the wavelength. So my advice is remember this wavelength, yeah, for visible light. So dari sini kau boleh tahulah sebabnya kalau you go to the right, the wavelength is decreases. The wavelength is decreases. But if you go to the left, then the wavelength is increases. So kira this visible light ni is a center lah. Okay. And we have the standing wave, we also have superposition, interference. So what I want you to do is try to practice lah. So look for this type of question, type of question in paper 1. Paper 1 answer past year paper booklet. Yeah, do as many as you can lah if you want to score about wave. And then we also have electricity. So electricity, of course, the first one is the electric field strength lah. So try to remember this formula, very important. This is for the parallel plate, and also remember the shape. I put a star there. This one will come out there. Yeah, so you must able to draw the shape of your electric field in the parallel plate. And then also all this formula that you see here, jangan lupa lah. So V equal to IR, V equal to W over Q, EMF is equal to walk done over Q, P equal to IV, P equal to I square R, and so on. So these are the typical formula that you must remember lah. And also this one, I also want to put a star there. This one also one of the question in your paper 1 this coming Monday. So you need to remember the relationship between EMF and internal resistance. Maybe I draw a picture here lah, just in case you don't know what is the R and the small r. So this one is inside the battery, and then this is the small r, this one is the E, this is the big R, and you have the current flowing. So this is the relationship. Alright, next one we have what do you hear? Oh, someone left already. Next one we have resistor. Kejap, I take a quick attendance here. Kacau this one. so I can check afterward. Yeah, there's another one over here for attendance purpose lah. Sorry. Alright, so for resistor, you must be able to remember all those calculation involving series, involving parallel. Not very yeah, not the direct one Kadang-kadang dorang ni jahat ni. Dorang macam show you macam ada macam mana case-nya. Ada 2-in-1 ya, something like that. Yeah. They'll ask you to find out the total resistance. Even worst case is they will give you some sort of a complicated circuit, then they ask you to analyze. All right, the next one, I put another star here again. Yeah, if you look here, I put another star here. This is another star one. So this will be also tested. Be careful this is an IV graph just to share with you Kalau kamu lihat ni is an IV graph. So for filament lamp, kalau IV graph, ia punya graph is going down. Okay Kalau kau terbalik dia punya kau terbalik dia punya graph. Let's say now you have a VI graph. So ia punya graph is macam mana ni? Yeah, it's going up. Yeah, it's going it's going up. Even worse. It's going up. Yeah, macam mana? So be careful the way is the variable nya tu Kalau I over V, ya turun. Kalau V over I, ya naik. Yeah. So please bear in mind for this. And the diode there is a sudden jump lah. Yeah. And last but not the least, we have the nuclear. Yeah. Nuclear kan banyak kan. Kalau you ingat, kalau nuclear, we have the alpha scattering experiment. This one, don't do that first. They are not the what is tested on this coming Monday will be this one lah. Decay. Yeah, decay. So let's say you have a unstable nuclei X 16080. If it emit alpha, what will be the new daughter nuclei? And then if it emit beta, what will be the new daughter nuclei? So something like that will come out. And then we have quarks. Yeah, so quark will be coming out. So the quark, normally they will ask you is about this one lah. Proton consists of up, down. Neutron consists of up, down. Yeah. So these are the things that will be tested for your paper 1 this coming Monday. Any questions so far? You want to ask me? Ada kan tanya?
Sir. Itu sir. Ini anu spring sir. Apa ni? Atas.
Ini ya?
Artinya sir, kalau dia tanya energi sir, sama macam mok danan sir. Macam mana tak? Ada?
Yes. So yes, correct. So this one, the area under here, it is also, we call it the strength energy. Sometimes we call it the elastic potential energy. Sama saja tu. Your term is all the same. Sometimes we just simply call them the work done. Yeah. Ada lagi soalan lain? Anybody has any question here?
Sir.
Yes.
Atau yang di bawah tu rubber band kan? Bukan plastik.
Oh, plastik. Kalau plastik, ia start to become cacat lah. So it's not I would say elastic still lah, but not in the type of plastic. Plastic meaning that sini lah tu plastik. Kira kalau yang dah balik arah kalau dah balik arah sini, this one we call it the plastic lah. Then it can going back here, we call it the elastic lah. Yeah, plastic elastic kejap let me show you Oh, sorry. salah channel. Awak kemarin baru I lihat the video ah. You remember kemarin I type the range of this distribution. Ada kamu beritahu, sir sudah type. Benar-benar sir belum type tu ah. I didn't type.
Ya toh.
Bukan sir,
Oh.
common question tu sir.
Sekejap.
Question.
Plastic and plastic deformation. So I have an image. Tu lah. Something like this one. Yeah, tu lah. I enlarge for you this one ah. So
Okay.
normally kalau plastic will be under sebelum the warna green color tu lah. Sebelum the green color thing. So kalau ia limpas the green color dot, the U point, then it will become plastic deformation. Meaning that ia nak lagi balik arah original length. So sebelum yang warna hijau tu, it should go back to the original place lah. This is plastic ah. So okay. Now, just want to explain about yesterday ada soalan yang we somehow hard to explain. I just go through the Google and then I managed to get the idea lah. So I like everybody to look at question number 22 here. Ini last sebelum we log off So question number 2 here, you have a longitudinal wave travel from left to right, has a vibration parallel to the direction of the transfer of energy by the wave. And then this graph represent the variation of distance of the displacement of the particle from their equilibrium position at one instant. So if you look at my drawing here, we have a compression, and then we have a rarefaction. We have another compression here, and we have a rarefaction and a compression. Now you need to imagine, that the center of the compression and the center of the rarefaction, dorang ni dah bergerak tu, okay? They were not moving. So kirakan if you have a particle at point C, it will not move. And if you have a particle at point R, it will not move also. So what is actually moved is the particle between them. So let's focus on C. Because C is a compression, all the particle next to the point C will be moving towards point C. Yeah, they are coming toward point C. A rarefaction, the particle is moving away because rarefaction is being stretched. So it will be moving away from particle R. So if you have a point C, all the particle arah you punya jiran itu will be moving towards C. Kalau point R, all the particle moving away from R. So let us take to the right is a positive direction. We take to the right is a positive direction. So this one is a negative direction, and then this one is a positive direction, and this one is a negative direction. Now look at the graph now. You look at the graph. The first part of the graph is a positive direction. That means the particle next to the center is positive. So you want to have a positive, that means it must be a rarefaction here. Okay, it must be a rarefaction. So here must be a rarefaction. Then we have a negative here, negative displacement of the particle. So negative displacement must be a compression. So this one must be a compression, and then followed by a rarefaction. So the center is actually the rarefaction and the compression. In between them is the displacement of the particle between them. This one. So yes, yesterday I also have a hard time to explain to you lah. So
Sir,
yes.
kalau you tanya center of rarefaction sir?
Center rarefaction will be either this one and this one. D lah tu answernya tu. Yeah. So A sama C has nothing to do with the center of the rarefaction, center of the rarefaction. A sama C itu kira sini betul. Tengah-tengah sini sama tengah-tengah sini. This one. Yang saya buat laser ni, tengah-tengah sini ni. Yeah, it will be here. The displacement. Yeah, so this is the one that we mix up lah kemarin. Yeah. Alright, so I don't want to take too long now, so we just go through quickly with everyone here lah. After this please make sure that you try the past year booklet. Cari soalan yang sebut atau buatlah balik-balik lah. Sekurang-kurangnya kamu ada practice half of them lah, ya, half of them. What I mean is half of them is kalau kau lihat sini ada sampai berapa? Sampai 15 you can see that there are 15 pointer I give you. So jangan pulang semua. I know is too much. Maybe dalam half of it, add or maybe 10, try to practice through the past year. Maybe tomorrow Ahad malam kah, we have another extra class, to help you to understand more lah. Kamu kan tanya saya apakah, we have another one session lah. It's not a compulsory for everyone for those who want to talk to me, see me or want to revise with me saja lah. Alright, we go through the flow here. Aiman, anything you want to share or ask?
Sir,
Yes.
kalau yang part momentum tu ada macam dia punya diagram tu macam ada before ni ada satu, let's say the ball lah sir. Ada 2 bola sir. Then satu remain at rest. Satu lagi moving towards.
Okay.
Lepas tu diorang ada collision, lepas tu diorang apa ni? Macam terform angle lah sir. Kira diorang tu split up 2.
Oh, sorry. Macam ni
Macam tu sir. Yes.
Nada apa?
Tu lah.
Nada atau nada? Jangan tak dulu.
Jangan takut sir. Alhamdulillah sir.
Nada.
Itu susah betul.
Ada lagi Aiman?
Itu sir, itu beri jawab sir.
Jauh. Okay. Okay, next we have Haswani. Ada suara. Something wrong with the mic. Ada. Yes.
Scroll ke bawah tu.
Scroll ke bawah. Okay. Arah mana tu?
Tu nah tadi tu. Lagi atas sikit. Lagi sir. Yang ada graph tu.
Ada graph.
So talk.
Talk ni. Ni Yes.
Kan kalau torque tu dia ada 2 force kan. So dia punya force Cak explain pasal torque macam.
So torque is macam mana? This is a torque. Kalau moment, so this one is a torque. This one is a moment. So torque is actually the force times the distance between them. Tapi perpendicular distance between them. Benarnya sama pulang actually. Cuma ia punya the distance itu dah sama. Kalau moment dari kalau moment is from pivot, this one is between them, between the two force. So itu sajalah. Tapi benarnya sama saja pulang tu. Moment itu is actually the same lah.
Jadi sir.
You cari yang macam mana dalam past year paper. Ada tu something like that. So You pandai-pandai carilah. Kalau ada, you show me tomorrow night. Yeah, I can discuss with you how to find it. Yeah. Faiza?
Tu sir, yang wave tadi sir.
Wave?
Ya,
Wave.
yang compression sama bla bla.
Yang soalan tadi kah?
Mana you punya center sir? Ada line tu, is it between the letters tu kah?
Oh,
Or
this is
ada
the
letter?
this is the center. This is the center, and this is the center. This is the center.
Okay.
This is the center. Oh, kira ia anda bergerak ke tak? Yeah, let me show you. Let me show you. Spring. Longitudinal wave. GIF. Masa bisa ya? Ini kali bisa. I want something yang kira enggak. This one what I want. I show you sekarang lah. Ya, I show you sekarang lah.
Okay.
I try to find the simulation so you can see lah. Yeah. Any other thing?
Okay.
Okay. This one is
okay.
Yeah. Fatin Naziha. Oh, okay. Not so good the connection. Cannot hear. Okay lah. Maybe not so good lah. Cannot hear actually. Ifa.
No question for now, sir.
Okay. So you have anything you ask me? Ruzain?
No, sir. Nada.
Okay. Alright. Thank you. Nazira?
For now, nada.
Okay. Anis?
No question, sir.
Alright. Kasrina?
No question, sir.
Okay. Kila?
Explanation, sir. Ada.
Apa tu?
Explanation.
Definition?
Explanation.
Anda berapa dengar?
Definition sir.
Definition.
Estimate is the estimate.
Estimation. Estimation ada. Nada. Yang macam ada macam ni kan? You mean the estimation yang macam ni betul? Let me show you. You mean macam ni kan? What is the reasonable estimation of a volume of an adult? Ini kan? Ini nada. Kalau soalan macam ni nada. Okay. Move on, Norizana.
Alam ada, sir.
Okay. Last three, Syahira.
Sir, best unit sir ada keluar kah?
Nada.
Ada.
No.
Okay.
Okay. Syazali.
Tidak ada, sir.
Okay. And last one, Wai.
No, sir.
Okay. So,
Sir.
okay. Yes.
So definition adakah?
Definition nada.
Nada. Okay.
Oh,
Nice.
yang macam
Nice.
correct orang atau nada. Okay lah. Kalau ada soalan, you may go now and do your revision . So tomorrow night we have another session. Kamu tanya saja lah kalau ada soalan.
Okay.
Sama Monday ada lagi last minute lagi. Hari Senin pun boleh juga last minute. Yeah. Kalau tak apa-apa, you can go now. I'll see you again tomorrow night and Monday again. Alright.
Okay, thank you,
bye.
sir.
Better.
Thank you.
Thank you, sir.
Thank you,
Alright.
sir.